So, welcome back, dear friends. So now only we saw different metallurgical processes. In that we will say enrichment of ore, or that is concentration of ore or dressing of the ore. First, in that we will discuss again types or that sub methods. Gravity separation, or we can say what hydraulic separation. So in that gravity separation method, we have to take one inclined plane. So in that inclined plane we have to some here grooves. We want here such type of grooves. So water we have to flow on this on the top of this inclined plane. So as you know, ore and impurities should have different densities here. So then we can apply this method. Whatever your ore and impurities, they must have different densities. So as you know, ore so much more density than your whatever impurities. So ore, whatever that after we are throwing here ore with impurity. So what will happen? Ore having highest density, that will fix in this groove, and whatever impurities will be what it can settle down with the flow of water. So yes, we will see again whatever your, suppose we will ore plus impurity we will add it here. So what will happen? Ore plus impurity if you added here, so whatever ore having a highest density, that will fix in this grooves, then whatever impurities we will settle down with the flow of water. So like that we can separate with this hydraulic separation, or we can say gravity separation. So what see the next here, magnetic separation. So in that magnetic separation, ore or impurity it must have magnetic property and another have a non-magnetic property. Then only we can apply this method, magnetic separation. Okay, so these are what physical. Whatever we saw, gravity separation also it is also physical method, and magnetic separation also physical method. So see here, suppose we added here ore plus impurities in that. So as you know, here two wheels are there in that their conveyor belt. Okay, so once you added here ore plus impurity, so whatever your ore, then what will happen? On this it will come here and see here, up to here only magnet is there. What? Up to here only magnetic. So what will happen? Here after magnetic is there, so whatever your magnetic ore having that property, they will fall down here. Then after that whatever non-magnetic part, so non-magnetic part is what your impurity, they will fall here. So here we will see your ore is what magnetic and impurity is what non-magnetic. So like that we can separate, okay, with the help of magnetic separation. So see here diagram also, ore plus impurity. Okay, so whatever next here, conversion of ore into metal oxides. So why we are converting into their metal oxides? So see, because of extraction of metal is easier from metal oxide. So why we are converting your ore into metal oxide? Because extraction of metal is easier from metal oxide. So see, after concentration, the ore is generally subjected to calcination or roasting depending on the nature of the ore. So these are new term for you, calcination or roasting. So we will see what is this calcination and roasting. So here roasting. So that's S, that roasting from that S. So basically it is for what? S for sulfide ores. So when we can apply this only for sulfide ores. So see, as we discussed ZNS, that zinc blend, then your cinnabar or that mercury sulfide ore. Okay, such type of ore we can apply this roasting process. So see, so this whatever this ore ZNS, we have to heat it in the presence of oxygen. Whatever this ore we have to heat, means heating in the presence of oxygen. Here we need of oxygen here. Okay, then what we call this roasting process. So after that, what you will get ZNO plus SO2. So we have to balance that reaction. Okay. Now see here next, calcination. So calcination, in that basically two ores we can separate: hydrides of oxide ore and second one carbonate ore. So in that hydrates of oxide ore, Al2O3 dot twice H2O solid, then on heating what you will get, Al2O3 solid plus H2 gaseous. In carbonate what will happen means, basically here what, no need of oxygen or heating in absence of oxygen. Okay, keep in mind here, in roasting, heating in the presence of oxygen, and in calcination, heating in absence of oxygen. Here presence, here absence of oxygen. So as you know, carbonate or calcium carbonate, limestone, that we can heat. So as you know, what you will get, CaO plus CO2 here. Okay, so this carbonate, whatever this calcium carbonate is there, limestone, here no need of this oxygen. Okay, so basically this important here, definition of calcination and roasting. So see here, in both the two things, in both whatever you're roasting and calcination, two things are same. Which two things are same here? That is a conversion of ore into metal oxide. So we want to, anyhow we have to convert into oxides, like that we converted here oxide, and moisture or water vapor present in the ore is expelled out after heating. So in this method also, whatever your moisture and water vapor will expelled out, and here also whatever moisture and water vapor will expelled out after heating. So see, both the calcination roasting is carried out in special type of furnace called as reverberatory furnace. So very much important is conversion of ore into metal oxide. Before that we discuss here magnetic separation, only magnetic ore, that we can only separate here. Okay, so whatever next part we will see in next lecture. Thank you.